All right. Hi, everyone. We're going to get started. So my name is Colby. I'm a product manager on the Azure Functions team. And today I'm going to tell you about 6 things that you need to know about serverless. So in this talk, I'm going to cover a bunch of different things. A lot of them apply to serverless in general. Some of them are a little more specific to Azure Functions. But in general, the idea is these are some kind of tips and tricks, some gotchas, some things that you need to know when you're developing serverless applications. So just because this is a 300-level session, I'm not going to do too much of an introduction into serverless and into functions in general. So this assumes a little bit of knowledge, but we get to go just a little deeper as a result. So cool. So thing number 1, without further ado, use our local development tools. With Azure Functions, we do support a variety of different ways to develop your applications. We allow you to code directly in the Azure portal, but we advise that to have the most success, we think you should use our local tools. So first and foremost is Visual Studio Code. We have really nice integration with VS Code. There's an extension. It's the Azure Functions extension for VS Code. Super easy to install. Just find it in the VS extensions little marketplace that they have there in the left tab. It's super easy to install, and then from there you can do all your local development information and also some of the outer loop as well of like deploying to Azure and management of your resources. In addition to that, we have Visual Studio tooling as well. So for all of you .NET developers out there, we have another set of tools for Azure Functions for Visual Studio. Very similar to the VS Code tools, lets you very easily get up and running with functions, deploy, etc. And last but not least, we have the Azure Functions core tools. So with this, it's actually a copy of the Functions runtime that's running up in Azure, local on your machine. So this is kind of utilized by the other two, essentially. But the core idea is with this, it's a command line experience that lets you use whatever IDE you want. So really, whatever experience you want to write code in, we support in Azure Functions. All right. Thing number 2, this is more of the next 2 are kind of more of little gotchas, things that people run into, anti-patterns we see. So the first thing I would say, process in batches. So when you're building serverless applications, you need to think about all of the other great programming practices that you've learned over the years. You can't just kind of assume that because we are handling all of the scale out, handling all of the infrastructure for you, that you can do things that don't make sense. So processing in batches is a really good example. Even though we scale to whatever you want, you should still be taking advantage of infrastructure, taking advantage of what infrastructure you already have provisioned. So what I mean by that is if you have an application that is, say, taking messages off of an event hub, you want to make sure that you're configured with that event hub to take a bunch of those at once, because each instance of the function, each execution can actually do more than just one message. So the way you configure that in JavaScript and in our other scripting languages is by using this cardinality property on the function JSON file. Or if you're using C#, it's in the type annotation, you can actually just set the event data to be an array. So that's just a nice little trick that I think everyone should take advantage of. It's the default in all of our templates, but we still see people that think that they should be doing one message at a time. But no, it does actually make a lot more sense to be doing to batch your processes. And I actually was running something I was running a workload like this just last week. I had maybe 100,000 events that were sitting on an event hub. And then I was initially not batching, and then I changed it to use batching, and it essentially kind of changed the performance for something that took, I think it was like an hour to handle all of the requests to something that took maybe 10 minutes. And just one other thing to notice, that when you are using event hubs, Azure Functions will only scale to the number of partitions that your event hub has, because we have to guarantee in order processing within a given partition. So bottom line is, for event hubs or for any kind of application where you're pulling things off of a queue, batch, it makes things so much smoother. All right, thing number 3. This is another kind of gotcha. Can anyone tell me what is the problem with this piece of code? That's correct. The HTTP client is being instantiated per execution. So this is an anti-pattern because if you're imagining you have a function that's scaling out really dynamically, scaling out to maybe 10,000 requests, this creates a new HTTP client on every single invocation of that function. And that's obviously not a good thing because creation of an HTTP client is expensive, and also it's not being reused. So because functions live on a function app, you can actually reuse some resources between them. So we advise doing things like creating static instantiations of your HTTP client What this will do is the first time it's needed, it'll go and create an HTTP client, and because it's a static resource, it'll be used by all invocations of that function. So this is a good way to get around that anti-pattern. We see people doing this all the time. It prevents scaling out properly. It's something that you should take note of when you're doing HTTP or even databases, things like that. Anything where you have to create a client connection. Another thing I want to announce, we announced this earlier today, the support for dependency injection. So if you're a .NET developer, you might be familiar with this. But the idea is now we have the ability to actually inject a service into the life cycle of your function. So you can say when you are creating up a function app for the first time, rather than, well, it's just a really good way to actually manage the lifecycle of that service and say this service will be available for the lifetime of a function. So this is the one that's probably the most common using this add singleton method. But the idea is you add this singleton method, add this singleton service that will kind of be there for the lifetime of the function. And whenever you have an invocation of a function, you can actually connect into this service that you've provided elsewhere. So take advantage of it. If you need it, you know you need it. And that's definitely a really great new capability that we announced this week. All right, so the first couple examples that I've gone through have been really focused on your inner loop development, so things that you're doing day-to-day writing code. What I want to say is I really encourage everyone, even if you're a developer that has an ops team elsewhere, you should consider your outer loop, and you should think about the things that kind of go around the lifecycle of your application. So the first and foremost, I would say, is monitoring. Application Insights and Azure Monitor is a really great tool, and we provision these by default for you whenever you create a function app. You can stream live metrics. You can go in and see, query all of the requests that you've seen to a function app in the last X amount of time. That just really emphasize you should absolutely be using Application Insights and in all of your function apps, and just that's kind of just the way to go. The other cool thing, this is enabled for our functions that have been triggered by Service Bus. Also, you can I should explain what it is first. This is the application app map in App Insights. The cool thing about this is you can actually trace the lifecycle of a given execution and see what actually happens as we're passing through there. You can go into this distributed network trace also and just kind of see what actually happened for a given invocation. But the cool thing here is that for particularly Service Bus, you can actually see how that function was passed between different function apps, or that invocation was actually passed between different queues and kind of going through Azure. So for other triggers in functions, this is enabled. Unfortunately, we don't have the lines yet, so you can see where the functions were triggered. You can see how kind of everything is stitched together, but the only one where you actually get the nice, really pretty traffic light graph that we see here is with Service Bus as of today. But we're looking at enabling more in the future. The next thing I want to say is that kind of along the same line of outer loop management of your function apps, I would say we are announcing this better integration with Azure Pipelines. So that's something that's new this week at Build. You could already use Azure Pipelines with Azure Functions in the sense that Azure Pipelines is a generic compute provider. It's a build service that lets you, configure your builds, add dependencies, ship that code up to Azure. So we supported Azure DevOps or Azure Pipelines supported Azure Functions because it supports everything. But what we've done is we've made the integration a lot nicer. So the first one is that in the dev.azure.com portal, we have nice templates for Azure Functions now. So if you go and search Azure Functions in Azure DevOps, you'll be able to see those templates, see what build steps are necessary for whatever language stack, and then kind of be able to deploy your functions however you need. The next one is in the Azure portal itself, in the Azure Functions portal, there's a deployment center. So this is a newer UX that we've released recently. The deployment center allows you to very easily configure, I would like my code to come from here, be built by this service, and deployed to here. So it's kind of a very similar experience as in the DevOps portal, but you're in the context of Azure Functions. And then the last one is that we actually recently released an Azure CLI command to do the same thing. It's AZ function app pipeline build create is the actual command. The idea here is that you are in the context of the Azure CLI on your local machine and you want to create a pipeline for the first time. It's a guided experience that will kind of help you get up and running off the ground. And then from there, you actually get the link into the dev.azure.com pipeline that you've gone and actually provisioned with this AZ CLI command. Cool, so moving on, we're going to get into thing number 5, and that is minimize or mitigate cold start. So this is actually something that's really important in serverless. It's something that you'll hear a lot of people talking about. Sorry, just opening my timer. Serverless is something that's unfortunately kind of a reality with serverless applications. Cold start is, for those of you who don't know, the fact that the first time you're making a request to a serverless function, you have to deal with some latency hit because we actually have to provision those resources for you. So because we scale to 0, we don't keep everything running at all times, and that very first time you have to go to a function, it'll get a little slower, essentially. And also, when you're scaling out, you'll see some small cold starts as well, because we're starting at one instance and then kind of getting bigger and bigger, so those new instances will take some time to get started as well. Those aren't quite as bad because you actually have the existing resource to go and keep connecting to. But sometimes this is a thing that people run into and have issues with. So a couple tips for dealing with cold start. First, JavaScript, TypeScript, C#, F#, Java. These are our GA languages, so the languages that we've put the most effort into optimizing. So JavaScript and TypeScript both run on Node, C# and F# both run on .NET and Java, so those are our three generally available language stacks. And the idea here is that we've put a lot of effort into optimizing these. These are the ones that you should be using for your production applications and are the ones that we kind of endorse as those that we have optimized and are kind of improving. So that's the first bit, use our GA stuff. Beyond that, I would say the next one is these two very uninformative icons. The first one is dependencies. That little bubble is supposed to say the things that you're bringing into your application. So if you're bringing the whole world into your application and loading it onto Azure, it's going to take longer to start. That's just kind of how things work. So all this is to say is if you have, say, a Node app with a giant NPM tree, make sure you prune that. Make sure you only actually ship up to Azure the dependencies you need in your application. Because obviously, as you bring in more and more files, as you have more and more dependencies, your stuff is going to take longer to start. And this one is, again, not a great icon, but it's just supposed to say, go with the stuff that we endorse. We have a lot of different technology. We have a lot of different configurations that you can use functions in. And what we advise is use the tooling that we have built in. So we have Visual Studio Code, we have Visual Studio. All of these pieces of tech that we've released already use the most optimized method. Like for instance, we have something called run from package. That's a kind of more advanced runtime technique that is kind of very confusing and dealt with more as a deployment technology. The core idea is you don't really need to worry about this. All it is it's we're actually running your application from a zip file rather than from loose files that are opened on your provisioned resources. It's actually really, really cool technology. It's like mounted entirely in memory. It's very, very cool. Anyway, the core idea is that this is an optimization that we take, that we do for ourselves that kind of makes a lot of performance improvements for a lot of our customers. And we do that by default for all of the deployments from local environments. So take advantage of that. Use the stuff that we advise. If you know what you're doing, by all means, get into it and do more advanced things. But the ones that we endorse are the ones that are the most performant in the vast majority of cases. The last thing I want to introduce is this thing that we released fairly recently called the Premium Plan. So Azure Functions can run in a variety of different ways. I've been talking about serverless thus far, which is the consumption plan. Serverless is where you get the dynamic scale to 0, and your application will respond to events, dynamically provision instances, etc. Azure Functions can also run in the dedicated plan, which is running on app service infrastructure. So you run your function in an app service plan alongside a web app or in its own set of resources. And what we've released recently is this premium plan, which I like to think of as kind of the best of both worlds. So the idea here is that you pay for at least one dedicated instance, and then you can scale dynamically on top of that. So with the premium plan, you get more advanced networking features. You get to run on better machines itself. So it is slightly more expensive. It's kind of the same price as a dedicated instance plus whatever dynamic scale you get on top. It's serverless in the sense that it scales serverlessly. You aren't paying 0. You're paying for at least one instance, so there is that base cost. But it's a really great option for larger enterprises who might want the serverless scale, but also need to make sure that there's no cold start at any time. So that's why I have mitigate cold start as well. You can kind of avoid the problem entirely by paying us for more resources. Cool. So last, thing 6, I will go into building serverless APIs. So this is a workload that I think a lot of people do, but doesn't get enough buzz, I think. It's a really, really good fit for serverless. Because of the fact that if you've got an API endpoint that you don't, I mean, it's an HTTP connection, it's inherently transient, you don't know when people are going to actually hit that endpoint, it's a really good fit for serverless because it can dynamically scale as you need it to. So this is kind of a classic architecture of maybe an application that you already have running. Maybe you've got 2 different servers, 2 different parts of your application built by different teams, perhaps, connecting to different databases. And what I would say is that serverless is a really good way to kind of modernize that. Maybe you need to go and rip out and build some functionality of one part of your application. So it's very easy to just replace one existing server with a set of serverless APIs. The cool part, though, is that you don't actually have to just replace things. You can actually tack them on. So imagine you have an existing API, and you just want to maybe add this one little endpoint that does some other piece of work on your website or something, like you're adding auth or you're adding some other module. I don't know. The idea is that it's very, very easy by using functions to kind of just put that alongside your existing API and kind of just going from there. It's very easy to get up and running. So that's one of the main scenarios when I'd suggest using serverless is modernizing an existing application, and the other one is building a new application. This is an example of an architecture I'm personally really fond of and is something that I definitely use. It is a single-page application, so you've got a statically hosted app. Maybe it's a React app, maybe it's an Angular app, and I don't have to worry about this big, clunky server. I only want to have simple serverless APIs that respond to whatever endpoints I need them to. Maybe I don't need them, but maybe I do have some state that I need to manage, or maybe I have some secrets that some logic I need to perform on the server side. And so this is a really good way of doing that. It doesn't need to be a NoSQL database, but the core idea is it's a really cool way of building simple applications. So that's one I endorse super heavily as well. So with that, I want to get into, that's the end of my talk, but I want to kind of talk through really quickly what is new in Azure Functions. We have this really cool event-driven programming model with Kubernetes. So Kata is something that we announced in a partnership with Red Hat this week. It's basically event-driven scale for Kubernetes. You actually can scale to 0 in Kubernetes, which is something that we couldn't do before. The way I like to think of this is just the scaling behavior of Azure Functions in Azure mimicked in a Kubernetes environment, which means you can really run it wherever you want. Premium functions I mentioned, so I won't go too deep there. We have a preview of PowerShell announced this week. Dependency injection I mentioned as well. Extension bundles. This is something that is one of those features that enables a lot of things for a lot of non.NET developers that you shouldn't have to worry about. But the core idea is rather than having to manually install extensions every single time you want to bring in a binding to your function, we will bundle those together as an extension bundle and then kind of configure for you how you actually go and negotiate that. So all this means is that for non.NET developers, you don't need to have .NET installed on your machine. So you don't need .NET to run JavaScript on Azure Functions anymore, which is really great and should have always been the case. But anyway, we have a Durable Functions release, Durable Functions 2.0. It has these stateful entities that are really cool. The streamlined Azure DevOps support, I realized as well. And then also something that I'd like to go into a little more detail, we have a new serverless library experience. So the serverless library is a really great, there we go. Serverless library is a really cool set of samples that people have built. It's an open source gallery of things that people have built with functions and other serverless technology. We recently improved the UX. We have the ability now to add samples directly on the site. You can see more details about each sample. You can filter. You can kind of go and search through to find your find things that other people are doing with serverless. I think it's really great. You should all check it out. Contribute a sample if you've built something with functions. And also, check out more serverless sessions. We have, these have already happened. This is me, so you already went to this. And then these are all of our other sessions as well. Check them out, particularly some of the longer sessions, like this one is going to be really great. Yeah, so thank you, everyone. That's it. I'll put it back on this slide for everyone to take pictures if you want. But yeah, thank you all for coming.